Hello and welcome. My name is Jean-Francois, working for Server Technologies curriculum at Oracle, and I will be your tour guide for this presentation. We are going to explore the basic architecture of grid naming services, also known as GNS, introduced with Oracle RAC 11G Release 2. When you are using Oracle RAC, all of the clients must be able to reach the cluster names. This means that all the cluster names must be resolved by the clients. By cluster names, we include the scan name and node names. For now, let's defer the explanation of the scan name to later in this presentation. Traditionally, you can let the clients know about cluster names by configuring your network files or your DNS server, indicating all the valid names and corresponding addresses. However, as soon as the number of nodes in your cluster is growing, this network administration part can quickly become cumbersome due to the number of entries you have to maintain. This problem is solved by the addition of the Oracle Grid Naming Service (GNS) feature to the cluster. The idea is pretty simple. Make sure GNS dynamically collects all the cluster names and addresses and passes them to your DNS server for client resolution as the number of nodes in your cluster evolves. To implement GNS, you must collaborate with your network administrator to obtain an IP address on the public network for the GNS VIP. This is the only IP address you need to provide during installation of your cluster. You must also collaborate with your DNS administrator to delegate a domain to the cluster. This can be a separate domain or a subdomain of an existing domain. The DNS server must then be configured to forward all requests for this new domain to the GNS VIP. Notice that as of 11GR2, one GNS server is tied to one particular cluster, and it must be allocated a unique domain of which to be in control. The GNS daemon and the GNS VIP resource run on one node in your cluster. The GNS daemon listens on the GNS VIP using port 53 for DNS requests. Oracle Clusterware manages the GNS and the GNS VIP to ensure that they are always available. This means that if the node on which GNS is running fails, then Oracle Clusterware fails GNS over along with the GNS VIP to another node in the cluster. Now, the question is, how does GNS get all the cluster names and corresponding addresses? This is done by two different means. In fact, it is during clusterware boot that the specialized agent ORA-root agent running on each cluster node requests that nodes VIP and scan VIP from your DHCP server. ORA-root agent then registers this information with GNS automatically. So, activating GNS in a cluster requires a DHCP service on the public network. As for the cluster node names, it is GNS that asks for hostname to address resolution using the MDNS process running on each cluster node. This is done using the MDNS protocol. The MDNS process sees all interfaces and addresses on a machine and associates them with host names. This process is also part of Clusterware. Note that MDNS is also responsible for GPNP, grid plug and play, process discovery in the context of node addition and removal, for example. However, we will not get into the details of GPNP in this presentation. Introduced with 11GR2 is also what is called the scan and associated scan listeners. The scan listener is basically the entry point of your cluster. It is there to load balance the incoming connections to your cluster nodes by redirecting the incoming connections to the least loaded node that supports the database service using the corresponding local listener. In your cluster, there are in reality 3 scan listeners. This is to avoid cluttering the listener when there is a lot of simultaneous incoming connections. The nice thing about scan listeners is that, although they each have a corresponding VIP, they all resolve to one name that is called the single client access name or scan name. The 3 scan listener addresses are VIPs because if a scan listener fails on one node, the cluster restarts it on another node so that you always have 3 scan listeners available. From a client perspective, the only information that is needed to connect to a database service is the service name and the scan name. To resolve that combination, the client submits a DNS request. By looking at the cluster domain name in the scan name, DNS is able to ask the corresponding GNS server, which in turn replies with the 3 scan VIPs. When the client gets back from DNS the 3 scan VIPs, it just takes one of them using client load balancing to get to one of the scan listeners. That scan listener is then responsible to redirect the connection to the least loaded node that runs the requested service via its local listener. Scan listeners obtain their load balancing information from the database instances, which have their remote_listener initialization parameter pointing to the scan listeners. This is the end of the presentation. Hope you find it useful, and thanks for watching.